Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today I want to discuss about what is Gauss Divergence Theorem, and by using that Gauss Divergence Theorem, how we can solve the problems. In the part 1 already I discussed some of the problems in the previous video. So here some more problems I want to discuss, and what are the different types of problems we are having in Gauss Divergence Theorem we are going to discuss now. See this. Verify Gauss Divergence Theorem for the function f bar equal to 4xi minus 2y square j plus z square k. So here, taken over the surface bounded by the cylinder. Here we are having the cylinder, that is x square plus y square equal to 4 and z equal to 0 and z equal to 3. Here we have to verify the Gauss Divergence Theorem. So already I given the outlines about the what is the verification and what is using the Gauss Divergence Theorem. If they are asking using Gauss Divergence Theorem means we can do only one part, that is nothing but we can do triple integral over v del dot f dv. That value is enough. Here they are asking verification means we have to do LHS part also. So that is double integral f dot n ds. So these two values we have to calculate and we have to show that the two values are equal. Then only verification will be complete. So here verify Gauss Divergence Theorem means what are the basic formulas or what is the basic values we should remember. We are going to see now. So first we should know about the what is the statement of the Gauss Divergence Theorem. So what is the statement of the Gauss Divergence Theorem? So you can observe here. So Gauss Divergence Theorem is double integral over s f bar dot n ds is equal to triple integral over v del dot f dv, del dot f dv. This is the statement of the Gauss Divergence Theorem. Here we should know about the ds and we should know about the del dot f and dv. So here first of all what is the given data we are writing? Given f bar equal to 4xi bar minus 2y square j bar plus z square k bar. Here to calculate the RHS part first I am doing del dot f. So already I told you what is the del operator, I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So del dot f equal to, here we are doing del dot f is, if you are taking f1i plus f2j plus f3k. So we are doing the dot product here, dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. So what is the f1, what is the f2, what is the f3? You can observe here. Based on the f bar, f1 is equal to 4x, f2 is equal to minus 2y square and f3 is equal to z square. So here we are replacing dou by dou x of f1, f1 is 4x plus dou by dou y of f2 is z square plus dou by dou z of minus, sorry, here f2 is minus 2yz minus 2yz plus dou by dou z of z square. So here we are doing with respect to x, this value is 4 into x value is 1. Plus with respect to y we are doing, so remaining 2 are constant, so minus 2z is constant, this is 1. And here we are doing with respect to z, this is 2z. So finally this is 4 minus 2z, this is y is the constant, right? So finally we got here minus 4 minus 4y plus 2z here, 2z here. So now we are going to do the value. So del dot f value is here minus 2yz, minus 2yz we are doing here, minus 2z, and z square is here 2z. So finally here this is 2y square. This is 2y square. That means this value is minus 2 is the constant into 2y. So that why we got here 4 minus 4y plus 2z. So finally del dot f is 4 minus 4y plus 2z. Now del dot f value calculated. So to evaluate this integral, we should know about the limits of x, y and z. How we can get these limits? We can observe here. They given the cylinder. What is the cylinder? X square plus y square equal to 4. And we are having the limits z equal to 0 and z equal to 3. So here already we know about the z limits. So z limits there is no issue. So we can take it as it is. So from this we have to take one variable and one constant. So here I am taking y as the variable. So y square equal to 4 minus x square. So finally y equal to square root 4 minus x square. Square root 4 minus x square. So here this is plus or minus square root x square. Here they didn't mention about the first octant. If they given first octant means we can take y equal to 0. But they taken over the surface, total surface. So based on that we have to take the value. So here we are taking y limits. So y limits are plus minus value to plus value minus square root 4 minus x square to plus square root 4 minus x square. So when you are putting y equal to 0, then x square equal to 4. X square equal to, so x equal to plus or minus 2, root 4 is 2, right? So this is minus 2 to plus 2. We can observe here z limits are 0 to 3. And here by the cylinder, x square plus y square equal to 4. From this we are writing y value. So y square equal to 4 minus x square. So y equal to plus or minus square root 4 minus x square. So y equal to minus square root 4 minus x square to square root 4 minus x square. So now we are putting y equal to 0, then x square equal to 4. So x square equal to 4 means x is plus or minus 2. So x equal to minus 2 to plus 2. Y limits are minus square root 4 minus x square to square root 4 minus x square. And z limits are 0 to 3. Now we got the limits. We can integrate the function here. So now z limits are 0 to 3 and this is z. And y limits are minus square root 4 minus x square to plus square root 4 minus x square. And x limits are minus 2 to 2. So now here, so this one dv means dx dy dz. So here first z limits are there, that's why we are taking this one as dz. And after that y limits are there, so dy, and last x limits are there. So we are taking here dy, dz, dy, dx. Now we are integrating the function. So integral minus 2 to 2, integral minus square root 4 minus x square to square root 4 minus x square. Here 4 minus 4y plus 2z is the function. And here z limits are 0 to 3, dz, dy, dx. dz, dy, dx. Now first I am doing with respect to z. So integral minus 2 to 2 square root 4 minus x square to square root 4 minus x square. Now I am doing with respect to z. So that means 4 is the constant. Integral dz, dz. Limits are 0 to 3 minus 4 into here integral y dy is y square by 2. Limits are, can we do with respect to y here? No, this is the with respect to z. That means 4 and y both are constants. So here 4 and y limits are, here integral dz, dz limits are 0 to 3 plus 2 into integral z, dz is z square by 2. z dz is z square by 2. Limits are 0 to 3 into dy dx into dy dx. Here 2 will be cancelled. So finally I am simplifying here. Integral minus 2 to 2 integral square root 4 minus x square to square root 4 minus x square. So now we are replacing the limits. 4 into upper limit minus lower limit minus 4y into, yes, same upper limit minus lower limit 3 minus 0 plus 2 will be cancelled here. 3 square minus 0 into dy dx. Now integral minus 2 to 2 integral minus square root 4 minus x square to square root 4 minus x square. So 4 into 3. 4 into 3 is 12. So here we'll get here 12 minus 12y. Here plus 9 into dy dx. That is only here we got 12 minus 12y plus 9. So we are going to simplify with respect to y and with respect to x. So now integral minus 2 to 2 integral minus square root 4 minus x square to square root 4 minus x square. So here 12 minus 12y plus 9 into dy dx. First we will do with respect to y. So minus 2 to 2. So here 12 is the constant. Integral dy is y. Limits are. And one more important point here I can tell you. So based on the simplification we can do the problems here. So first 12 plus 9. 12 plus 9 is the constant. So we can do the simplification here. This is 21 minus 12y into here. We can observe if it is the value minus a to a into f of x dx is there, we can write this value as integral 2 integral 0 to a f of x dx if it is even function. If it is odd function, we can write a 0. This is the basic formula you should remember. Then it will be easy for you. You can calculate as it is also, but you will get the same value. If you using this, we can simplify the equation very easily. So now based on this, we can write this one as integral 2 integral 0 to 2 and 2 integral 0 to square root 4 minus x square into 21 minus 12y dy dx. That is only we wrote here based on this one. So 2 integral 0 to square root 4 minus x square 21 minus 12y. So here we are doing that one. So here 2 integral 0 to square root 4 minus x square and here integral minus 2 to 2. This one is 21 minus 12y. That is only we got here 21 minus 12y into dy dx. First we will simplify with respect to y. So minus 2 to 2 integral. First we are doing with respect to y, right? So in 21 into dy, integral dy. So 21 integral dy is y. Limits are 0 to square root 4 minus x square minus 12 into y is integral y dy is y square by 2. Limits are 0 to square root 4 minus x square 2 6 are 12. So into dx. Now we are simplifying this one. 2 integral minus 2 to 2. So 21 into square root 4 minus x square minus 0 minus 6 into y square. That means 4 minus x square into dx. Now this one is here 2 integral minus 2 to 2. So 21 into square root 1 minus x square minus 6 into 4 minus x square into dx. First we are going to simplify this one. After that we can do with respect to x. So here we can observe this one as, so 21 here. So 21 and 2 both are constant, taking out. So this is 2 into 21. We can write this one as 42. So 42 integral minus 2 to 2. So here this one is, so 21 21. 21 already we multiplied here. Square root 4 minus x square minus integral minus 2 to 2 6 into 4 minus x square into dx. So here we are getting this odd. If it is odd function, we can write this is the 0. So that's why we got the only first. So now this is 42 integral minus 2 to 2 y. Limits are 0 to square root 4 minus x square into dx. So now we are substituting the limits. After that we can do with respect to x. So 42 integral minus 2 to 2. So square root 4 minus x square into dx. Now we are simplifying this according to the same definition. So if it is even function, we can write that one as a 2 integral 0 to a. So 42, this is the even function. So here we are writing this one as 2 integral 0 to 2 square root 4 minus x square into dx. So now 4 into 2, here 42 into 2 is nothing but 84. So 84 integral 0 to 2 square root 4 minus x square into dx. 4 minus x square into dx. So here we are having the formula for the a square root a square minus x square. So based on that formula we are going to simplify here. 84 integral 0 to 2 square root 4 minus x square into dx. So we are having the formula a square minus x square. So based on that, that is a by 2 x by 2 square root a square minus x square plus x square by 2 a square by 2 sin inverse x by a. So based on that formula, so if you want I will write the formula here. A square minus x square integral dx equal to x by 2. Here a value is 2, otherwise ax by a square root a square minus x square plus a square by 2 sin inverse x by a. This is the formula. By using this formula, we are writing here 84. So x by 2, a value is 2 here in place of a2. So x by 2 square root 4 minus x square plus a square is 4. So 4 by 2 sin inverse x by a. So limits are 0 to 2. So here when you are replacing the limits here, 4 minus 4 is 0. So first term is 0. Next here this one is 2. Sin inverse 2 by 2 is 1. So sin inverse of 1. So now 84 into first term is 0 plus 2 into sin inverse of 1. We can write here one value. What is the sign value? Which sign value is 1? Based on that we will write here 84 2 into sin inverse of 1 value is signed. Pi by 2 is 1, right? So sin inverse and signed. So we'll get the pi here, pi by 2 here, 84 into 2 into pi by 2. So 2 will be cancelled. Finally, I got 84 pi. This is the value of triple integral over V del dot f dv value is 84 pi, 84 pi. This is the RHS part. So next we need to do LHS part. What is that? So we have to calculate double integral over S. F bar dot n bar ds. F bar dot n bar ds. Here, what are the surfaces for the cylinder? Based on that, we can take. So this is the cylinder. So here we are having 3 surfaces. We can observe in the figure here. So here this is the x-axis and this is the y-axis. This is the surface 1. This is the surface 1 and this is the surface 2. This is the surface 2 and this is the surface 3. So we have to calculate double integral over S along these surfaces. We can add these 3 to get the total surface. So this is one we are observing here, x, y and z, and this is the, so this is z axis, x, y. So this is surface 1 and this is surface 2 and this is the surface 3. So we are calculating double integral over S f bar dot n bar ds along the surfaces S1, S2 and S3. After that we are adding to get the total surface value. First we are taking along S1. So along S1 means this is the bottom we are taking as S1. So this one is in the which plane? XY plane. This is in the XY plane. This is in the XY plane. On the xy plane, z value is 0. In the xy plane, z value is 0. So z is 0 means dz also 0. And when you are considering the xy plane for the ds is dx dy by n dot k. So according to that, ds is we are taking dx dy, and n bar here upper value we are taking as a k bar and bottom we are taking as a minus k. So n bar equal to minus k. According to that, first we are calculating f bar dot n bar. So f bar is 4xi minus 2y square j plus z square k dot k is minus k. K is minus k. So I dot k is 0, z dot k is 0 and k dot k is 1. So finally we got here minus z square. We got here minus z square. So already we know the what is the z value in the xy plane 0. That means this value is 0 square, nothing but 0. So f dot n ds values we got 0. So 0 into ds is nothing but 0 only. So finally surface along along the surface S1 we got f bar dot n ds value is 0. That means first surface value is 0. Now we are going to calculate S2. Then we can get the value here. So now along S2. This is S1. This is the top value is S3 and this is S3. So now top surface that is S2. So along S2, this is also in the xy plane. So before we take in this vector is minus k bar. Here we will take only k bar. So in the xy plane, what is the z value? Already we got here z equal to 0. Here z equal to 3. So here z equal to 3 means dz value 0 only. So ds is dx dy, n cap is k bar. Now I am calculating f bar dot n bar. So 4xi minus 2y square j plus z square k dot this is plus k. So I dot k is 0 first term and j dot k is 0 second term. Next third term z square. Third term is z square. Already we know that z value is 3. That implies 3 square. That value is 9. So f dot n value is 9. Now we are going to evaluate the integral. So double integral over S2 f bar dot n ds equal to double integral over S2 9. F dot n value is 9 dx dy. So to evaluate this integral, we should know about the x and y limits. Otherwise, if you know the area of the circle, this will be easy for us. So here 9 is the constant. Double integral over R dx dy is nothing but the area. So what is the area of this surface? This is like a circle. So this is the circle area. So 9. So we can take this one as a dA. dA is nothing but 9 into area of the circle. Area of the circle because the surface is circle. So area of the circle. So that is 9 into pi r square. What is the radius here? R equal to 2. Based on that we are calculating 9 into pi into 2 square. So we got here 36 pi. This is the value of surface 2 f bar dot n bar ds value. So this is second surface we got 36 pi. For the first surface we got 0. Now we are going to evaluate the third surface. What is the third surface? This surface is like this. This is the first surface. This is the second surface. And this is the third surface. So this is the curved surface we are calculating here. Given cylinder is x square plus y square equal to 4. We are taking this one as a pi. So x square plus y square minus 4. X square plus y square minus 4. Now we are going to calculate the unit normal for this value. So first of all, to know the unit normal, what is the formula? N cap equal to del pi by det of del pi. What is the del pi value we are calculating here? Del pi is I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So 2xi dou pi by dou x value with respect to x we are doing, so x square is 2x. With respect to y we are doing, this is 2y. So this is 0. So finally 2xi plus 2yj. Now we are calculating data of del pi. So here square root 2x whole square, that is 4x square, 2y whole square, that is 4y square. So already we know that. So taking out 4 is root 4 is 2, square root x square plus y square. Already we know the value x square plus y square is 4. So root 4. So 2 root 4 is nothing but 2 into 2, that is 4. So del pi value is 4. Here 2xi plus 2yj by 4. So we are simplifying here, taking the 2 common, xi plus yj by 4 here. We are calculating 2 times. So finally we got, this one is xi plus yj by 2. Xi plus yj by 2. This is the n cap value. This is the n cap value. So after calculating the unit normal, we are using here cylindrical coordinates. You can convert and to calculate the value of f bar dot n bar ds for the curved surface. Here we are taking x equal to 2 cos theta and y equal to 2 sin theta and ds equal to 2 dz d theta. So z varies from 0 to 3 and theta varies from 0 to 2 pi y, because we are taking the total sum. So total area. So now f bar dot n cap. F bar dot n cap is, f bar is 4xi minus 2y square j plus 2 z square k dot n cap is xi plus yj by 2. So now we are doing the dot product I dot I. So that means 4x into x by 2 plus j dot j. So here j dot j is minus 2y square into y by 2. So here this is 2 times, so 2x square, and here 2 will be cancelled. This is minus y cube. So f dot n value, I got 2x square minus y cube. Now we are going to replace x and y limits. Here y values here. So x is 2 cos theta. So 2 into 2 cos theta whole square minus y is 2 sin theta. So 2 sin theta whole cube. So here this is 2 into 4 cos square theta minus 2 cube is 8 into sin cube theta. So 8 cos square theta minus 8 sin cube theta. So now we are simplifying. We can write in place of cos square theta, we can write that is 1 plus cos 2 theta by 2 minus, for the sin cube theta we can replace the formula 3 sin theta minus sin 3 theta by 4. So now we are simplifying that, double integral over S3. So f bar dot n bar. So 8. So theta limits are from 0 to 2 pi and z limits are 0 to 3. Z limits are 0 to 3. So 0 to 2 pi and 0 to 3. So we are replacing here the values, f bar dot n value 1 by 2 plus 1 plus cos 2 theta by 2. We are dividing the values, 1 by 2 plus cos 2 theta by 2 minus 3 sin theta by 4 plus sin 3 theta by 4 to dz d theta. Now we are doing first with respect to z. So theta, all theta values are constant, this value is constant. So integral dz limits are 0 to 3. Now we are replacing. So 3 minus 0 is say 16 into 3, so 48. So finally now we are doing with respect to theta. So 1 by 2 is the constant, integral d theta is theta. Integral cos 2 theta is sin 2 theta by 2. Integral sin theta is minus cos theta, and here sin 3 theta is minus cos 3 theta. So now we are replacing the limits 0 to 2 pi. We got here 48 into 2 pi by 2 plus 3 by 4 minus 1 by 12 minus here 3 by 4 minus 1 by 12. When you are cancelling these terms, so finally we got here 48 into 2 pi by 2. So 2 will be cancelled. We got 48 pi. We got 48 pi. Now this is the along the surface S3. So LHS equal to along the 3 surfaces. For the first surface, we got along S1 plus along S2 plus along S3. So along S1 we got 0 plus along S3 we got 36 pi plus along S3 we got 48 pi. So when you are adding this, we got 84 pi. So LHS value we got here 84 pi. So already for the RHS part, here we got 84. That means here these two values are equal. LHS equal to RHS. LHS equal to RHS. That means double integral over S f bar dot NDS equal to triple integral over V del dot F dV. So we proved the theorem. Hence, Gauss Divergence Theorem is verified. So that's why if they're asking to verify the Gauss Divergence Theorem, we have to calculate LHS part and RHS part. For example, if they're asking using the Gauss Divergence Theorem, only one part is enough. So I hope you understand this problem. If they given the cylinder problem, we have to analyze like this, and you can get the idea to solve the problem. So if you want more information about this type of problems, please go through these references. So here you can take the textbook Engineering Mathematics written by T.K.V. Iyengar, and you can use the mathematics textbook written by B.S. Gravel, and we can use one more author also, Engineering Mathematics written by B.V. Ramana, and some of the Google links you can use here. I used these Google links. If you want the more information and some more problems, please go through this and do the problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.